Yeah, start the recording. So let me share the screen. And let's get started. Welcome to our review meeting. We are looking at the 1.120 release today, which already got released, I think, 1 or 2 weeks ago. But yeah, due to the hackathon summary last week, we are a bit late in schedule. So we have 1.120 today, and next week 121, and then we should be back in the regular 2-week cycle. Okay, so there are 4 topics. Sebastian will show us the single stack IPv4 to the dual stack migration for GCP. Then we have Nikolai, who will present the recently merged CAP34 about OpenTelemetry operator and collectors. Third topic is from Oliver, actually one from the hackathon that we missed to present last week about cluster internal L7 load balancing for the kube-apiservers. And finally, Tim will show some new fields about compatibility in the extension API. Then let's start with Sebastian and the first topic.
Then let me directly start. I want to show you basically a demo of the GCP IPv4 to dual stack migration. I hope you can see my screen. Let us directly start with the layout, how it looks in IPv4. So in IPv4, we have a VPC, and in the VPC, we basically have on GCP 2 subnets. So basically subnets where the nodes reside in, and one for the internal load balancers. And also, if we look at the route table without overlay, so basically the Cloud Controller Manager creates for us the routes. So where we basically route via the instances to the destination range. So then I will show you what will change once we will migrate to dual stack. To trigger the migration, we have to edit the IP families in this shoot spec. So we basically have to add the IPv6 field, and then the migration will be started. We will see a constraint which will be added to the shoot. So the shoot is migrating to dual stack networking, and it has the status false and dual stack nodes migration ready. So basically what will happen at the first step, this is a longer step. So in the first step, the infrastructure will be reconciled to support dual stack. This will, or in the beginning, happen relatively quickly. For example, if we look now at our VPC and the subnets, we see that we have now added to the internal and the node subnet external IPv6 ranges, and that we also created a subnet for the services, also with external IP addresses. Also, what will change since we use since we use dual stack load balancers later on, we have to deploy the Ingress GCE into our control plane, and Ingress GCE will use alias IPs, and therefore we have to also add a secondary IPv4 range to the nodes. And in order to do that, the routes have to be deleted, which CCM uses. Wait, I have to select the zone. But until this will take some time until the routes from the Cloud Controller Manager get deleted. Once we have deleted it, in order for the cluster to function, so we have to add those routes as alias IPs to the network interface card, to the NICs on the VM. Therefore, once we delete it, we write that routes, or once the controller manager, GCP controller manager leads into the infrastructure state. This will take some time. So we can watch what the Ghana extension provider GCP does in the meantime. No, that's not. That's unexpected. Okay, usually the API server, the seed response. Sorry for that. Okay. I don't know, maybe some hiccups. So this will take some time. At some point in time, the routes will be deleted, and then we will see that the routes fill up in the infrastructure state, and then we will update the instance with alias IPs. Basically, this is the first step in the migration process. This will happen right after you update the IP families right here. Now the routes are added, so you see the destination side as the instance name and the so on. And if we look at the instance, for example, in the beginning with IPv4, so there's no alias IP range because we have the routes in the route table. And once the routes are added to the NIC, this might take some time, we will see the IP address here, so for v4. And this is the first step. So the next step would be you have either, if you want to migrate right away, you have to delete the nodes. Otherwise, to get the dual stack nodes. Otherwise, this will be done with the next Kubernetes update or once the nodes get recreated and they get IPv6 addresses. So it looks like the routes are now updated. They're removed from the infrastructure state, and now we see the alias IP range here on the interface, and everything works. So the cluster still works. Okay, now after the infrastructure is updated, we could delete the nodes to speed up the process. So let me delete the machines. Also in the shoot, when they will join, we can take a look. They should usually have some the IPv6 addresses. Also, we can reconcile, and this should then also be reflected in the constraint. So basically, that the nodes memory created to dual stack migration ready. So we will see the update once the nodes join. Yeah, this will take some time. And once the nodes have joined, we would need another reconcile then in order to update the remaining components, like the kube-apiserver. So we have to also add for the service nodes and so on the IPv6 ranges. And also Calico has to be or will be updated then depending on the constraints, so that we will enable IPv6 or dual stick networkings in both modes. Yeah. As a whole migration will take some time. Yesterday, I tried it one time. It took around 12 minutes. So hopefully this time a little bit faster. So we have 2 nodes running. We can now declare a cluster and take a look, and we should already still achieve. Oh, that's unexpected. Also, yeah, we also in the infrastructure states that the subnet range now and the service range, which is IPv6. The reason node deletion was also a little bit too fast. I guess I should have waited a few seconds longer. Let me just. Not. Yeah, but since this will take some time, I can also hand over to my predecessor and then show it afterwards. The migration will take some time at the end, once it's done.
Yeah, okay. Let's do it this way. Any questions so far before we continue with the next topic?
We've also documented since this, there are multiple steps required since the whole, or since until the migration is done. So we also have documented that under the Garden extension provider GCP and also under Gardener. So you can also look that up. Usually this would happen without disruption, but if you want to happen it right away, then you need to do all the steps which I just showed you, and then it takes some time.
Quick question, Sebastian. There's no IPv6 only shoots possible in GCP, right? So we only have this path.
Yes, yes. Unfortunately, in GCP, not in AWS. Yes.
Yeah. Okay. Thanks.
All right. Dan, thanks for now. And let's continue with Nikolai and GAP34 then.
Right. Okay. So GAP34 is now merged or has been accepted as a proposal for introducing the OpenTelemetry operator and collectors in the shoot control planes. And it's part of a longer initiative about bringing OpenTelemetry data format, transport protocol, and semantic conventions for observability signals in Gardener, or in short, observability 2.0. So I'm not going to spend much into overall picture, but in concrete details of what actually GAP34 brings from this entire picture. It starts with bringing the necessary components that manage the life cycle of the collectors through which observability signals will pass through. And here I'm not talking only about logging, but also about metrics, although GEP34 is specific for logs or target more or less logs types of transportation, collection, and storage. In concrete, OpenTelemetry operator will be brought in onto the seeds through which it will manage the lifecycle of OpenTelemetry collectors per shoot. So each shoot control plane namespace will have a dedicated OpenTelemetry collector, and the purpose of which is to actually transport the observability signals for this particular shoot, where the sources of these signals can differ. In GEP34, of course, there are two primary sources for through which logs or OpenTelemetry logs will be passed through these collectors. So the first one is actually the shoot nodes. So as you know, today on the shoot nodes, we have an active engine called Valitail, which goes and scrapes the systemd logs and then sends them to the backend. But now the idea is to actually unify this and replace this vendor-specific implementation with a standard-based approach. So there will be a collector, part of the implementation plan in GEP34, which will scrape these logs and send them to the collector on the shoot control plane, which lifecycle is managed by the community-driven operator, OpenTelemetry collector operator. And then this one of the sources. The other source is, of course, the log shippers, which are running on C. They also will push the logs through the OpenTelemetry collector in the corresponding format, which would allow us in later phase to actually replace the OpenTelemetry logs backend. So today we have this Valley, and in the community there could be others which are using. But the idea is to bring the OpenTelemetry data format, and then you can have any type of backend which can store OpenTelemetry observability signals. For the concrete implementation of needs in Gartner, in our environment, we will be replacing Valis on the backend with Victoria logs, which is OTel enabled. But that is not only the only vendor that can be feed in these logs, can be shipped to a Datadog or ClickHouse or even Loki if somebody is still using that. So it doesn't really matter as long as either the receiving part of the storage is OTLP enabled, meaning it can ingest OTLP logs into the backend, or the collector part has the corresponding exporter, which can go and push the logs into that backend. And the benefit of the operator is actually the ability to bring a different distribution of collectors tuned for the particular environment, meaning that now we have a complete flexibility in how and where we want to push observability signals. We can store them per tenant based, so per shoot control plane storage, or they can be set centrally. It doesn't really matter because it's just a question of delivering the corresponding resource definition for the resource, for the OpenTelemetry collector resource with the pipeline, and so on and so on. That being said, the GEP34 deals particularly with logs. However, we just a few weeks ago, we experiment with the idea to also tunnel metrics from the shoot nodes through the OpenTelemetry collector, which will be brought by the this GEP34, and that seems to be quite actually not even possible, but there is a better, quite a few benefits coming with that approach. So that probably will be something that we'll tackle probably later this year. So we'll see whether we'll keep push the pull model or go with the push model for metrics. Probably will start conservative and still use the pull-based approach by allowing metrics from the OpenTelemetry collector on the shoot nodes to be pulled from the Prometheus on the shoot control plane, but still taking the benefit of having a filtering abilities or conserving network utilization traffic for all the metrics that we want to pull from the shoot control planes. And yeah, I mean, even thinking what I'm saying now is about the future, but there are even more interesting ideas coming from the community. So even the brighter future about it right now, you know, AI is quite a prominent topic. And to me, personally, I was looking into this idea, and probably the MCP is the game changer that would make a big difference for how large language model and observability data can be worked together. So right now I see some vendors like Dynatrace, they are writing an MCP server which allows them to connect to an LLM model and scrape a certain information from their backend. So for example, Dynatrace can be used primarily as a backend to store observability data there. So logs, traces, and metrics, they support all three of the signals. And now with the MCP, it gets really interesting based on the prompts that can be sent towards the backend using the large language models. And I think the first steps, we are far, far away from these scenarios, but the first step into getting there is to allow the observability data to flow with a common data format and vendor agnostic transport protocol. So this is a prerequisite to get into the state where we can even go and think about much more complex scenarios and architectures. So with that being said, this is a rather new topic in my opinion, the whole observability 2.0 idea. So as a community, you're invited to go and let us bring this into the Gartner ecosystem together. There are many things to explore and innovate, and I really like the whole area because it's really moving fast, and there are a lot of things that can be done with this technology stack, so to say. Right. Okay. So that's everything from me. GEP34 is out there. If you haven't checked it, please give it a read, and of course engage us with any type of ideas or feedback or any questions that you might have. I'm more than happy to answer those and to bring this into a discussion. Okay. Yeah. That's from my side.
Yeah. Thanks, Vicky. Any questions so far? Any feedback? By the way, are the reactions working for you? Because for me, it's not working. Just try to send some applause emoji, which is not working. Okay.
I saw it.
You saw it. Okay, I didn't see it.
There was quite some applause.
Okay. Well, then Next one would be Oliver with the cluster internal L7 load balancing endpoints.
Hello, hello. You should be able to see my screen now. As Raphael mentioned, this topic is a hackathon topic. It's not included in the release yet. We just forgot it last week. This is all about the layer 7 load balancing. You might remember the previous hackathon, so the one in November, we kind of invented layer 7 load balancing for the shoots in the virtual garden. However, this was for the external endpoint only, so not for internal control plane components like Gardener Controller Manager, Cube Controller Manager, Gardener Resource Manager. So all the components which are running for the shoot case, let's say in the shoot namespace, and trying to access the Cube API server. And while we tested this feature, we noticed that there are a couple of components which cause quite a bit of load to the Cube API servers or the Gardener API servers. The most important component here was the Gardener Controller Manager, which was creating heavy load on some of our Gardener API servers. So we had the idea for this hackathon to support layer 7 load balancing for internal components too. And when you check the Istio documentation about this, you might end up in with a proposal like introduce Istio service mesh and so on to create such things. But this was, in our opinion, too much effort and too many changes for something we just do in a hackathon. So we chose a kind of lightweight version. And this lightweight version was that we leverage the existing scenario and we use the generic token cube config we use for many control plane components and simply exchange the address here. Before we used the internal Kubernetes service, and during the hackathon we replaced this by the public resolvable address. The one where we created the load balancing for during the last hackathon. And by doing that, we would use the Istio Ingress gateway setup and the load balancing, which is already in place. This would be just a change of, I don't know, 5 lines of code. But there's one thing we tried to avoid, and this was external traffic, because depending on the load balancer configuration, when you use the external public resolvable endpoint, so the external IP, you might create external traffic to access the Cube API server. And we wanted to avoid this. And to do this, we created a kind of additional cluster IP service for the Istio Ingress gateway pods. And we are using this now for the load balancing. And in order to achieve this, we defined some host aliases in the pods which try to access the Cube API server, and some network policy labels that they are able to access them. And to make it convenient, let's say we do this by another webhook in the Gardener Resource Manager. I can show this in a minute. yeah, we also documented the changes. So the overall flow, is it? Just a second here. The overall flow will look like this, a bit smaller. So the flow for the external clients has been already in place. So entering the cluster via the load balancer, the Istio-Ingress gateways doing the TLS termination, and we have two separate paths for clients authenticating via tokens and via client certificates. Yeah, that was already existing. All we added is this cluster internal service, and this cluster internal service is used by the internal clients. Yeah, and I prepared a short demo for this. I'm using our operator setup, created a garden and a shoot, and yeah, so I'm able to present both cases, I guess. Okay, first let's focus on the case for the virtual garden. We can start with the generic token kube config. So there's a generic token kube config in the garden namespace for accessing the virtual kube API server. And before the change, there was something like virtual kube APIs, HTTPS virtual kube API server in there. And now we have replaced this by the external address. And when you check now a pod, so in the garden namespace, like the Gardener controller manager I mentioned, there are two. You see here, by the way, that it's using the generic token kube config. And what we did in order to support this scenario was, one thing is we added via the webhook I just mentioned this label here that the network policy to access the virtual the Ingress gateway is created, and we created, or the webhook creates host areas for the here this host name, the external address of the virtual garden kube API server. And when, in case you wonder where this is pointing to, you see here, this is the new Istio-Ingress gateway cluster, cluster IP service. So the traffic is using the Istio-Ingress gateway path, but it's staying internal. Okay, so last step here, we see, let's check if it's really load balancing. Second. Here we go. So you see here we have two instances for the kube API server. And as a really small test for this, we check the Istio logs for the client of here the Gardener controller manager. Generate some logs. Okay, enough logs. And now we can search for the IP addresses here of both pods. And you see some of here, probably at the moment, Gartner Controller Manager is not doing many things because it's nearly empty, this task. Yeah, you see it's probably updating its leases or its lease, and it's some requests are going to this instance of kube-apiserver and others to that instance. So you see that the load balancing is actually working. Okay, and say similar for the shoot case. We check the control plane namespace here of the shoot. And again, the secrets. No. Where is it? There. And here, the same thing. You find the external address in this generic kube config as well. And when we check a pod, like the kube controller manager, we can see the label and the host alias. This time it's pointing to a different IP, but only because this thing is using a different load balancer. Yeah, and basically the test is the same. This time we have 3 instances of the kube-apiserver for the shoot, and we check for kube controller manager this time. And again, it's updating its leases here. And when you check for the IPs, we find a few of the first kube-apiserver instances. We find occurrences of the second. And last but not least, of the third one. Yeah. And with this, yeah, we are also able to balance load of our internal control plane components. Yeah, basically, that's it. Any questions?
Yeah, for the virtual kube API servers, can you elaborate a bit why such a pretty complicated setup is necessary as compared to choosing, let's say, the go-away chance flag?
Yeah, the go-away chance, when you just configure the go-away chance, the controller is also accessing one kube-apiserver at the same time only. So it's just switching kube-apiservers. But once it's connected, it's firing all the requests to the single instance. And maybe after 2 minutes, it's sent away, and then it's connecting to the next kube-apiserver. But yeah, firing all requests to this one, and this is because of this HTTP2 connection, where yeah, the controllers create one single connection and fire all requests through this single connection.
Right, but that's perfectly fine if you have enough clients, right? I mean, the whole point is to balance out the clients to the instances then, which works good enough, I'd say, if you are the person controlling the clients. Yeah, so you can't really shield against like malicious clients who do, I don't know, 100 times more traffic than all the others and so on. That's true. And that's why I was asking about the virtual kube API servers, because like most of the controllers connecting to it would be ours, right?
Yeah, that's true. But at least here for this Gardener controller manager, we found out in some landscapes that they could create a heavy load, not on the kube API server, but on the Gardener API server behind this. There's only a single instance active for the Gardener controller manager. Yeah, this is the one case we observed here, and we don't have many clients here. That's why this internal load balancing here could be beneficial too.
If there is no more feedback, we still have one topic from Tim and follow up from Sebastian, and let's switch over to the last topic for now by Tim, for extension API changes.
Okay, thank you. So I'm presenting this change, this pull request. It's adding two enhancements to extensions and controller registration APIs. The one is the auto-enable, and the other one is the cluster compatibility fields. Let's start with auto-enable first. So to give you a little bit of context, so this is a very simple extension resource. It could also be a controller registration resource. It's the same here. And earlier it was, sorry, I meant to, so this one. Earlier it was possible to define in the resources section for the kind extension. So this is the generic extension kind that Gardener has, something that is called globally enabled. And this globally enabled field, it instructed Gardener to create extensions for every shoot cluster there was or there is, even though the shoot cluster did not explicitly enable that. So one example is you have a DNS service for your shoot cluster and you'd like to activate it by default, then you would put this globally enabled field to true and all the shoots get it without any further configuration. Everything is done from the operator. Okay, with the change now, maybe we can show this side by side. So with the new fields, we deprecated this globally enable field and instead introduced something that is called auto-enable. And the 101 replacement here is that you can define that it is automatically enabled for all shoot clusters. So why did we do that? As you probably know, we brought extensions not only to the shoots, but in the last couple of months also to the garden and to seed clusters. So what you can do with this new field is, of course, you can also say something like you want to automatically enable it for all seed clusters in your landscape, and you can also do it for the garden cluster. I mean, there is no big benefit for the garden cluster as there is only one, but from the consistency point of view, it's of course better it's nice to also define the garden here. So this is like the replacement then for our globally enabled. And another question that comes along is, now that we have extensions for shoots, seeds, and garden, how does the extension itself define if it's compatible or to which cluster type it's compatible to? Because at least, or especially in the beginning where we introduced this new ability to have extensions for seeds and garden, not all of the extensions really support that use cases. And therefore, we introduced another field, which is called cluster compatibility. So if you define a cluster compatibility for shoot, this would correspond to the, let's say, old behavior that you only have this extension defined for shoot clusters. But if an extension was adapted and let's say a certificate extension can now also request certificates for garden and seed clusters, then the extension would typically do something like this, right? And with that in place, we have a validation in the background that you can only enable certain extensions for the right cluster type.
Different thing.
Okay, let's play around with that a little bit. Okay, here we go. So on the left, there's the garden runtime cluster. And we have this provider local extension defined. And again, what would be interesting to look at is we have this one. It says we have the extension is compatible with shoot and garden. And on the left side, on the right side, we have the garden cluster. There's the controller registration resource. Let's look at that. So we have this one here. And this says it's compatible to shoots. Why does it only say shoots? Because the controller registration is never responsible for the garden cluster. So it cut out the garden and then created the controller registration with this cluster compatibility type. So let's take this type and try to activate this extension for the seed cluster. Then it would say it's not valid, right? So you cannot enable an extension that is not compatible with seed cluster types. So what we can do is, let's say the extension was now adjusted and it's now compatible with seeds. We can edit the extension. And say this one is now also compatible with seed clusters. Save it. Let's look at the controller registration again. It's now active for seed clusters. And let's try to. Sorry. All right, now it works. So the seed now defines this extension. And it was activated. Okay, and actually the same goes for the auto enable. So if I now would put the auto enable for the seed, then of course the extension would automatically be enabled for the seed that we just edited. Okay, that's already it. Thanks.
Well, thanks, Tim. Any feedback for this topic before we get back to Sebastian? Nope. Okay, then let's continue with Sebastian's topic.
Okay. Basically, in my local setup, the Cliverno webhook got broken, so I have to investigate. So in the meantime, I've also created one cluster on our dev landscape and basically did the same. And just to show you now, after migration, so basically we have on the instance IP stack type IPv4 and IPv6, and also the external IP address is now on the VM. So if we now look at the port, for example, the black box exporter, we see that it now also have an IPv6 address and also sets the host as IPv6. So basically sets it. So after the migration is done, all pods have to be restarted, and then they will come up with dual stack IP addresses. Any question?
Nope. Okay. Then we can wrap it up. That were all the topics for today. Thanks everybody for coming. Thanks to all presenters. And as said in the beginning, we will meet again next week already for 1.21. Have a nice time. Bye-bye.
Bye-bye.
See you.
Thank you.
Bye.
Bye.
Bye-bye.